For question number 36, sorry, this is the first case study based question and it's based on overspeeding, which increases fuel consumption and decreases fuel economy as a result of tire rolling friction and air resistance. And vehicles reach optimal fuel economy at different speeds. Now, the fuel mileage, we know all know that usually decreases rapidly at speeds of 80 km per hour. This is the graph given for the fuel consumption at different speeds per 100 kilometer. And the relation between the fuel consumption for every 100 kilometer and the speed v, that is kilometer per hour, is given by this relation f is equal to v square by 500 minus v by 4 plus 14. And on the basis of above information, we have to answer the following questions. The first one is where we have to find f when v is 40 kilometer per hour. So we are going to use this relation for the first one. So for the first one, we have to find the fuel consumption, which will be in liters for every 100 kilometers. So let's put in the value of V, which here. So V is 40. So this is 40 square by 500 minus 40 by 4 plus 40. So 40 square is 1600 divided by 500. This is 10. Negative 10 plus 14 is plus 4. Now this is equal to 16 by 5 plus 4, which is equal to 5. 16 plus 20, that is equal to 36 by 5 liter per 100 kilometer. This is the fuel consumption when the speed is 40 kilometer per hour, that is 36 by 5 liter for every 100 kilometer. Okay, and let's move on to the second part. So the first one is done. 36 by 5 liter per 100 kilometer is the fuel consumption. For the second part, we have to find the so the second part we have to find the rate of change of fuel consumption will be F is equal to V square by 500 minus V by 4 plus 14. That is, we have to differentiate this with respect to V. So differentiating this respect to V, we get V times that minus, this is now 1 by 4. Differentiation of V is 1. So 1 by 4 and differentiation of 14 is 0. So this is 250. So that means df by dv is equal to 1 by 250 and v by 250 minus 1 by 4. And, and let's keep this for future reference. So this is our df. Okay. So we have got df by dv. Moving on to the third part. For okay, the third part has choices. So we are going to solve both these. So we have to find the speed v for which fuel consumption is. Okay, so for fuel consumption is minimum. Let's find out the first order differentiation which we have got. And for minimum fuel consumption, we have to find the value of v. So for minimum or maxima, so for minimum fuel consumption, our first order derivative should be equal to 0. So that means v upon 250. So v by 250 is equal to 1 by 4 and 1 by 4 into 250. 4 6 that is 24, 22.5. So the speed is 62.5 kilometer per hour. And we have to check whether at this speed fuel consumption is minimum or not. So let's find out the second order derivative. So second order derivative would be, this would be 1 by 250, which is greater than 0. So that means f is minimum when speed is 62.5 kilometer per hour. So F is minimum when speed is 62.5 kilometer per hour. And let's move on to the next one. Okay, for B part of the same question, we have to find the quantity of fuel required to travel 600 kilometers at speed v. So df by dv is given rate of change of fuel consumption with speed is given, which is negative 0.01. So we have got this df by dv, which is v upon 250 minus 1 by 4. So this is v upon 250 minus 1 by 4 is equal to negative 0.1. I can write this as 1 by 100. So this is 250 is equal to 1 upon 100 plus 1 by 4, LCM is 100. This is 1. And this is now 4 2 is 8 and 4 5 that is 20. So V is equal to 26 by 100 into 250. Okay, or rather, let's so 25 10 that is 250, 25 4 that is 100. This is 2 to the 4, 2 5 that and 13, which gives me y is equal. Okay, this should be this is 26 upon 100 into 250. Let me calculate it once again. So this is yeah. Now 1 by 100. This is 100, 26. Minus should be 24. So this gives me 60 kilometer per hour. So V is equal to 60 kilometer per hour. Now we have to find the quantity of fuel required to travel 600 kilometer at speed V. So speed is 60 kilometer per hour. And let's find out the quantity of fuel required. So let's use the given equation F, find out the fuel consumed at 60 kilometer per hour using this equation. So this is 60 square by 500 minus 60 upon 4 plus 40. So this is 3600 by 500 minus 60 by 4 plus 14, which gives me 36 by 5 minus this is 4 under 4, 4, this is negative 1. So this is 36 minus 5 by 5, which is equal to 31 by 5 kilometer per. So this is 31 by 5, and which is equal to 6.2. So this is 6.2 liter per 100 kilometer. Because this gives us per 100 kilometer consumed. So that means for 100 kilometer at this speed, 60 kilometer per hour, it's 6.2 liter. And we have to find it for 600 kilometers. So for 600 kilometers, that should be 6.2 by 100 into 600, which gives me 6 to the 12, 6 6 36, 37. So that should be 37.2 liter. Okay. Moving on to question number 37.